told you that earlier, but maybe. Now this is a finite automata for sure. And if I now see this mapping, it is not one-to-one mapping, because here I am mapping this to two of the states, na? 0 1. As far as 2 raised to q is concerned, it is 1-to-1. 2 raised to q में से एक को मैंने मैप किया है, लेकिन 0 1 यानी q कितने q को मैप किया, q सेट में से दो लोगों को मैप किया 0 1. जब मुझे 3 को मैप करना होगा, दैट इज आई मीन टू से दैट ऑन इनपुट 0 आई मे बी ऑन in state 0 on input A, I may be moving to state 0, state 1 और state 2. ये कहने के लिए मुझे मैपिंग किसके साथ करना पड़ेगा, इसका मुझे मैपिंग करना पड़ेगा ये सबसेट के साथ. Okay, so what I'm trying to do actually is I'm trying to do a mapping between the subsets. That is what I'm trying to do when I'm trying to represent a delta for an NFA. So delta for NFA has a mapping which is q cross sigma mapped to 2 raised to q. Now we were looking at distinctive points between a deterministic FA and non-deterministic FA. Similarity in these devices that both are finite automatas, both are acceptor devices. So they will both be given as input one string, and if the string is a valid string, they will return at the end of the
सर फिर से वॉइस ब्रेक हो रहा है.
one of the final state. Okay, let me check. Give me a second. From my side, the signal strength is okay. Maybe a connection problem at your end. Anybody else is also facing the same issue of voice getting broken?
Yes, sir.
Okay, wait. Then.
No, sir. No, sir.
Okay.
No,
Some
sir.
of them are not. Yeah, some of them are not experiencing. Others are experiencing. Maybe the recording will be clearer because my side the network is good today. मेरा कनेक्शन बीच में लैपटॉप का ये हो गया था, बैटरी लो हुआ था, तो उसके कारण शायद थोड़ा बीच में एक्सपीरियंस हुआ रहेगा. Okay, the point that I want to make here is, first of all, I want to tell you what do you mean by power set. Power set होता है हर एक कोई भी सेट में लूँ तो उसका मैं power set create कर सकता हूँ. Power set of any given set is set of all subsets of the original set. So 0 and 2 के subsets कौन-कौन है? Phi is a subset of the set. Original set is also a subset of the set. All the sets having some of the elements from original sets are subsets. So 0 1 2 length 1 के subset है. 0 1 0 2 1 2 length 2 वाले subsets है. Okay. What is the cardinality of 2 raised to q? Cardinality of 2 raised to q always is 2 raised to cardinality of q. Okay, so 8. So you can understand that there are these many kind of mappings possible. मेरा जो second side है, right hand side है, वो 2 raised to q होने के कारण now I have so many number of subsets to map. Now this mapping can be one-to-one mapping, but is it onto mapping? Onto कब कहलाता है कोई मैपिंग? जब राइट हैंड साइड का सेट है वो पूरी तरह से पार्टिसिपेट करता है. यहाँ आप देखोगे राइट हैंड साइड सबसेट में, राइट हैंड साइड के सेट में मेरे पास 8 एलिमेंट थे, 1 2 3 4 5 6 7 और 8. इन 8 एलिमेंट में से एलिमेंट नंबर 6, एलिमेंट नंबर 7, एलिमेंट नंबर 8 has not taken a part into the mapping, and I have this mapping as many to one mapping. Okay, correspondence 1 to 1 है, okay, लेकिन on to नहीं है, तो ये total function नहीं है. This is not a total function. Please remember that the mapping for NFA is not a total function. Mapping for DFA is a total function. We just try to understand why it is not a total function. The mapping for DFA, as we said in the previous slide, here mapping of delta in DFA is defined as delta colon q cross sigma arrow q. Mapping for NFA is written as delta q cross sigma mapping ka le arrow 2 raised to q. So that's the difference between the notational specification of mapping, and this mapping makes NFA non-deterministic. The mapping of DFA makes DFA deterministic. The reason behind DFA is deterministic because this mapping is a total function. NFA mapping is not a onto mapping. That breaks down the requirement of being a total function. One to one onto means a total function. NFA is one-to-one mapping between Q cross sigma and 2 raised to Q. Please understand, DFA is mapping between Q cross sigma and Q. We are saying that Q cross sigma and map to Q should be one-to-one onto mapping. Then delta is a total function, and we are talking about DFA. Q cross sigma map to 2 raised to Q, in fact, inherently says that you are allowing non-determinism because now the function mapping can be onto. Function mapping can be onto. तो एक criteria break कर रहे हो, 1 to 1 onto का criteria आप break कर रहे हो, for that not being a total mapping. Okay, total function, sorry. I hope this idea is clear. What is a non-deterministic finite automata? What is a deterministic finite automata? Given a transition diagram, how to identify the automata being a deterministic or non-deterministic. Now, before we go to the next topic, I want you really to think about and come up with an answer to this, whether this second device that you look at, is it a deterministic device or is it not a deterministic device? Now you'll find that इनमें से दोनों में से ट्रांजिशन बहुत सारे सेम है, लेकिन ये वाला ट्रांजिशन का लेबल अलग है. ओके, एक ट्रांजिशन का, ये दो ट्रांजिशन के लेबल अलग है. बोथ हैव 4 ट्रांजिशंस, 2 स्टेट, 2 अल्फाबेट सिंबल्स. यानी 4 क्रॉस 4 अगर उसका 2 क्रॉस 2 अगर उसका टेबल बनेगा क्यू क्रॉस सिग्मा का, तो वो 2 क्रॉस 2 टेबल में 4 सेल्स में हर एक सेल में एक पर्टिकुलर इनपुट जाएगा, राइट? और एक एग्जैक्टली एक ही इनपुट जाएगा. इनिशियल स्टेट डिफाइंड है दोनों में, फाइनल स्टेट डिफाइंड है दोनों में. यानी दूसरा भी एक डिटर्मिनिस्टिक फाइनाइट ऑटोमेटा है, राइट? इस पर्टिकुलर ऑटोमेटा के लिए क्यू सेट में क्या है? कैपिटल क्यू में Q0 Q1. सिग्मा सेट में क्या है? 0 1. इस डिवाइस में क्यू सेट में क्या है? Q0 Q1. सिग्मा में क्या है? 0 and 1. तो दोनों के Q और सिग्मा कंपोनेंट इन द 5 tuple definition are same. Okay, but what is different? Even the initial state is same. So Q0 is same. So capital Q, sigma and Q0. These 3 things are common for the device 1 and device 2. Now what is the difference? There are 2 differences. One difference is for the first automata Q0 is final state. So F set में Q0 है. In the second automata F set में Q1 है. Okay, I guess that is the thing that you can visualize and understand. Fine. As far as delta is concerned, they also differ in delta. कहाँ differ करते हैं? Q0 के transition में नहीं differ करते. On 0 you stay here, on 1 you go here. On 0 you stay here, on 1 you go there. So first row जो है मेरे transition table का वो same रहेगा इसका और इसका. लेकिन second row जो है Q1 on input 0, this stays in Q1, whereas Q1 on input 0, this goes to Q0. तो मेरा second row जो है उसमें ये दोनों ऑटोमेटा डिफर करते हैं. How they operate or how they simulate the string will be different. Why? Because their transition table or transition function differs. So इस पे 2 चीजें डिफरेंट है दोनों में, पहला और दूसरे में. ट्रांजिशन टेबल डिफरेंट है और आपका एफ सेट डिफरेंट है. तो ये दोनों तरीके हो सकते हैं 2 अलग अलग डीएफएस को डिफाइन करने के. ओके, एंड दिस मेक्स these device behave differently for same input. दोनों का अल्फाबेट सेम होगा, यानी मैं सेम तरीके का इनपुट दोनों को दे सकता हूँ. फॉर इंस्टेंस आई कैन गिव 1011 as input to this device and also to this device, क्योंकि दोनों का सिग्मा सेम है. सिग्मा सेम है तो ये सेम इनपुट में ये दोनों डिवाइस को दे सकता हूँ. सिमिलरली आई कैन गिव द सेम इनपुट टू दिस डिवाइस एज वेल, बिकॉज इसका भी अल्फाबेट सेम है. सॉरी, इसका भी सिग्मा सेम है, अल्फाबेट सेट है. ओके, इसका भी अल्फाबेट सेट 0 1 है, इसका भी अल्फाबेट सेट 0 1 है, इसका भी अल्फाबेट सेट 0 1 है. Now, if I give the same input to these three devices, they will produce different set of answers. 1011 पहले डिवाइस को मैंने इनपुट दिया, तो हम लोग देखते क्या होता है. So one input will do what? Take me into Q1. Second input, which is 0, will place me in Q1. Then again 1 takes me to Q0, and a 1 takes me back to Q1. So what this device ends up in is Q1 state. Q1 state is non-final for this particular DFA. So it says that this input is not accepted. Okay, this will be the answer. Now 1011 on this device, 1 0 0 will take me back to Q0, then 1 and 1. I will end up in Q1, and Q1 being a final state, this device will accept my input 1011. What about this third device? I'm in Q0 initially. On input 1, I go over here. Okay. On input 0, I go to Q2. And now you will find that this Q2 is an interesting state. Once I reach Q2, can I move to any other states in my automata? Consider that you reach Q2 somehow. Then from Q2, can I go back to any of the states, any other states?
No,
No,
sir.
I cannot go. So such states are referred to as trapped states. These states are referred to as, sorry, should use black, yellow color. Sorry. These states are referred to as trap states because we are trapping the input that is coming to the device. Okay, this is a trap state which is a non-final trap state, but I may have a trap state which is a final state as well. So there are various ways in which I can define trap state in an finite automata. So this is a new thing. We have learned a concept called as a trap state. We till now talked about initial state, final state. Final state is drawn by two circles. Initial state is drawn by a dangling arrow, which is not starting at any point in any other state. And now we have learned the concept called as trap state. तो Q2 में एक बार पहुंच गए 10 इनपुट देख के आप Q2 में पहुंच जाते हो, and then whatever you see, you still remain in Q2. Q2 being final state, this will also reject my input. Okay, so this is how these three devices simulate the same kind of input. They are able to simulate same kind of input because their alphabet is same. Okay, their alphabet set is same. Okay, they have different queues though. This has Q0, Q1, Q2, three states. This has two and this has two. इन दोनों में states भी common है. इन दोनों में initial state भी same है. Okay, तीनों में अगर देखा जाए तो initial state Q0 है और alphabet set common है. Okay, so this is how you can compare different, even the deterministic finite automata. I'm not saying or I'm not asking you this question, but you can understand that Q0, Q1, Q2 इसमें तीन state है और alphabet में दो symbols है 0 and 1. How many transitions will be there or how many cells will be there in my transition table? There will be 3 into 2, 6 cells will be there because there will be 3 rows, 2 columns. 3 rows किसके लिए? Q0 का एक रो, Q1 का एक रो और Q2 का एक रो, and 0, 1, 2 columns. Okay, so there will be 6 cells and you can find 6 distinct labels for every state. Q0 0 वाला लेबल है, 1 वाला लेबल है. Q1 के लिए 0 वाला लेबल है, 1 वाला लेबल है. Q2 के लिए 0 वाला एक लेबल है और 1 वाला एक लेबल है. तो हमारे पास 6 डिस्टिंक्ट ट्रांजिशंस है जो आपको एग्जैक्टली वन नेक्स्ट स्टेट में ले जा रहा है, यानी इसका डेल्टा टोटल फंक्शन है, यानी ये डिवाइस डिटर्मिनिस्टिक है. आई होप दिस आइडिया ऑफ what is a deterministic device, how to identify a deterministic device for any FA, how to list out Q, sigma, Q0, delta and F is now clearer to you. ये सब चीजें आपको क्लियर है possibly after this discussion. We have today extended ourselves one bit or one notch up by saying in these categories of devices that we were talking about here. Okay, FA without output, we now know how to define a deterministic FA and how to define a non-deterministic FA. We know that delta for deterministic FA is going to be Q cross sigma mapped to Q, okay, which is going to have an additional property of being a total function. And for non-deterministic finite automata, its transition function is going to be Q cross sigma mapped to 2 raised to Q. So now we know two kinds of devices in this particular category. One is called as deterministic finite automata, second one is called as non-deterministic finite automata. I hope these things are clearer to you. We know that whenever we are simulating an FA on a particular input, what we do is we check out in what state the device ends up when I complete the simulation. If that state is a final state, then I say that given input is acceptable. Second thing is, if I collect such all strings which are acceptable by my device design, okay, then such set is referred to as language of that finite automata. So if I'm representing finite automata with a symbol M, the language of finite automata is represented by L of M, which is a set. So if the device is represented by M, which will be a phi tuple representation of the device, which is finite automata without output, then L of M is the set of all strings that are accepted by M. Okay. Now we know for a deterministic device, since the device is deterministic, I can simulate a string and say whether that is acceptable or rejectable. And then I can keep on accumulating all the strings which are acceptable into a set and produce a language set for the given automata. But for NFA, is it that simple? No, it's not that simple. The reason behind that is, since the device is in shows a non-deterministic behavior, we will not be able to identify whether the device accepts or rejects an input string that easily. इतना स्ट्रेट फॉरवर्ड तरीके से मुझे ये डिटरमाइन नहीं करने आएगा. So tomorrow's lecture we will identify how to define a language for NFA. क्योंकि language for FA जो था वो definition काफी है for saying language of a DFA, because DFA being a deterministic FA, we can simulate any string and identify whether it is accepted or rejected. If we collect all acceptable strings, then that is the set called as the language for the DFA. Okay, so we'll stop our discussion here. You can put your name and roll number in the chat window and leave the session. Okay, we'll continue this discussion about language of NFA in the next lecture. We'll take an example of an NFA and we'll try to define the language of NFA in the upcoming lecture.